Hi everyone, I'm Teacher Law and welcome back. Today we are going to solve some questions by using the concept of integration as the inverse of differentiation. Before we start, let's go through the content standard as well as the learning standard. As usual, let's recall the previous lesson that you have learned. The example here shows that the differentiation of 4x squared is equals to 8x. You are asked to find the integration of 8x with respect to x. The symbol here indicates the operation of the integration, while the x means the integration is done with respect to x. So, as we understand that integration is the inverse of differentiation. So, if we check the terms given here, which is 8x, and the differentiation for this is the 8x as well. As what we have learned, integration is the inverse of differentiation. So when the terms given are exactly the same, therefore, the answer for this will be exactly the same like the differentiation given, which is 4x squared. Let's start questions number 1. Given the differentiation of 4x cubed minus 2x squared plus 5 is equals to 12x squared minus 4x. Find the integration of 12x squared minus 4x. From the understanding that integration is the inverse of differentiation, so before we determine what is the answer here, just check through that whether the terms given are then the same or not. So 12x squared minus 4x. 12x squared minus 4x. Yes, they are exactly the same. So what we need to do is we just copy what is given from the differentiation. That is 4x cubed minus 2x squared plus 5. Don't you think that is simple? Do remember, if the terms given from the differentiation is exactly the same like what you are given in your integration, therefore, we may just copy the answer from your differentiation. Let's go to questions number 2. Given that the differentiation of 3x over 2x squared plus 1 is equals to fx. Find the integration of fx. Again, we have to check that the function here is exactly like what is given, what you have get from your differentiation. If they are exactly the same, that means the integration of function fx, we can just take from what we have learned, that is the inverse of your differentiation. So the answer for this will be equals to 3x over 2x squared plus 1. What do you think? Is it very simple? Alright, let's go to question 3 now. Question number 3 is the differentiation of a function is equals to 2gx. Now you are asked to find the integration of function gx. If we look at the answer from the differentiation here, where you have a 2 in front of the function gx, whereas the integration here, we don't see the 2 here. So in that case, we cannot straight away do what we have done for the first 2 questions. That is, just take the inverse of your differentiation. So what we need to do now is we have to get a same coefficient for the function gx. So how can I do that? First of all, if I want to have a 2 in front of the function gx here, and with the 2 in front, how can I get back the original questions where I don't see a 2? That means this 2 actually, what I need to do is I got to multiply by 1 over 2. Okay, when you simplify this, you will get back the original questions itself. Okay, you get back the same questions, that is the integration of gx alone. So with that, the 1 over 2 will be remain there, whereas the 2gx here is the inverse of your differentiation, that is your fx. So this is the answer for integration of function gx. Do you think you can understand it? Let's continue with the next questions. Questions number 4. Given f prime actually is the differentiating of 2 minus x over x with respect to x is equals to negative 2 over x squared. Again, you are asked to find the integration of 1 over x squared with respect to x. So if we compare these two figures here, again, we'll notice that they are slightly different, where actually there is a negative sign for your differentiation and there's a number 2 there. But if I look at my questions, my question is the integration of 1 over x squared. So what I need to do in order to get the same answer for your differentiation from here. So again, I need to have a minus 2 there. So maybe I can write in this way to make your understanding. That is, this time I'll put a negative 2 over negative 2. That means when you simplify it, you'll get back this. Then I'll put here 1 over x squared dx. Now, this time, I'm going to move this negative 2 in, we multiplied it with 1 over x squared. So, the denominator will remain unchanged, whereas this negative 2 now is here, times 1 will get this. And what am I going to write for this empty space? I put it as 1 because 1 times negative 2, I'll get back 1. Actually, what am I doing is I just exchange the position of these two numbers. Then you'll see that we have negative 1 over 2. Now, this is what you can see from your differentiation. So from what we have learned, integration is the inverse of your differentiation. So that's how you get the next answer for it. Alright? So that is the answer for. And the conclusion is, just remember, differentiation is the reverse of your integration. Same thing for your integration, that will be the inverse of your differentiation. So in general, dy dx for a function fx which is equal to f prime x, then the integral of f prime x with respect to x will be the inverse of it. That's how you get it done. Okay, that's all for today's class. Thank you.